Hello ladies and gentlemen, today we're going to look at reviewing slope and graphing linear equations. What you're going to want to have around you right now, you're going to want to have your notes, calculator, and a writing utensil of some nature. So your learning targets for this particular video. I can determine slope of a line three ways: by using a graph, using a table, and given 2 points. You can graph a line using slope-intercept form. And you can algebraically determine if two lines are parallel, perpendicular, or neither. Sloping of a line. You guys probably remember this. The slope of a line is the steepness of a line, or as it rises or falls. It's also the rate of change of the line. We normally thought of it as rise over run, or the formula for it, y2 minus y1 over x2 minus x1. And remember, slopes can be either positive, negative, zero, or undefined. Now, you're probably asking, what do those look like? I can't remember too well. Well, what these look like. This one is a positive slope. Notice how it looks like it's going uphill from left to right. That is positive. When it looks like it's going downhill, that is a negative slope. And when it's going horizontally, it's a zero slope. It's not going up and it's not going down. What about when it's vertical lines? Well, those are undefined. That doesn't make sense. It'd be 1 over 0 for our rise over run. That's why it's undefined. So from geometry, if you guys can pull back from that information, parallel lines are lines that are in the same plane that never intersect. And perpendicular lines are lines that intersect at right angles, aka 90 degrees. So why am I bringing this back? Well, we can have parallel and perpendicular lines in our graphing as well. So what about parallel lines? What do we know about their slopes? What do we know about perpendicular lines? They actually are really easy to figure out. So if you have two lines that are parallel, then the slopes are the exact same. So if I have one slope of a half and another slope has to be a half if they want to be parallel, which makes sense, right? If they're going at the same speed or same constant rate of change, they have to be the same. Otherwise, you would start crossing over. If I have two lines that are perpendicular, then the slopes are negative reciprocals of each other, aka it's flipped and then the sign has been changed. So if it would be 1/2, it would be -2 for my slope. So let's kind of refresh back. Let's see if these lines are parallel, perpendicular, or neither. So I have a line that goes through the point 3, 0 and -1, 2. And I have a line that goes through 1, 0 and 3, 4. So I'm going to use that y2 minus y1 over x2 minus x1 formula. So let's do that here. I'm going to call this x1, x2, y1, x2, y2. There we go. I actually got it this time. Okay, so y2, I said that was 2. Subtract my y1, which is this guy right here. That's 0. Over x2, -1, minus x1. There we go. So I got 2 over -4, aka -1/2. Let's check this one. So this is my x1, y1, x2, y2. So y2 is 4 minus y1, which is 0, and 3 minus 1, x2 minus x1. 4 over 2, which is 2. So I have -1/2 and 2. Well, they're not the same, right? They're not both -1/2 or both 2. But -1/2, if I flip that, that's -2, and then change the sign, it's 2. So these two lines are perpendicular to one another. Okay? Now, a linear equation. That's pretty much what we're looking at right now. A linear equation is an equation that uses x and y and also graphs into a straight line. You've seen linear equations before, probably since middle school. Those have been around. Now, the solution to a linear equation is basically a point xy that works in the equation and makes the equation true. So let's actually try this for a moment. I have a point 5, 4, and I want to see, does that work in here? Is that a solution? So I'm going to plug this 4 in for y and the 5 for x. So 4 equals 2 times 5 minus 6. So I get 4. Sorry about that. 4 equals 10 minus 6. 4 equals 4. Well, that does work. So yes, it is a solution. Pretty easy, right? Check the point, see if it fits. Now, what does it mean to be a solution? And what does this graph do? Well, a graph of an equation in x and y is a collection of all the points whose coordinates are solutions. So, and remember, the x values are the domain and the y values are the range. We already covered that. So if I look here at my graph, and if I graph all these points here, I know that those are all solutions to my equation. So if I have this really awesome graph here, and I start graphing some points in here, I have solutions. So each dot I put on that graph, I have actually solutions to my equation. Now, if you guys remember, a very common way that we graphed our lines was slope-intercept form. Slope-intercept form is y equals mx plus b, where m was the slope of our line and the b was the y-intercept of the line. Kind of remember that? So if m was our slope and the b was our y-intercept. Let's try graphing. You're going to want to do a little coordinate plane in your notes just so you can kind of graph this out. So let's use y equals mx plus b. So I got to solve for y. So I'm going to subtract 3x first. And I'm going to do 2y equals negative 3x plus 4. Divide by 2. Y equals negative 3 halves x plus 2. Kind of writing crooked there. Let's graph this. So I'm going to start at my y-intercept, remember. So that's positive 2, and it's a y-intercept. So we're going to start on the y-intercept right there. And then we're going to use our slope. So down 3 over 2. Down 3, 1, 2, 3, over 2, 1, 2. Down 3, 1, 2, 3, over 2, 1, 2. Up 3, 1, 2, 3, over 2. And so on. And let's see if I can connect them. Ooh, that's actually not too bad. Usually I do worse. Alright. So I have graphed my line y equals negative 3 halves x plus 2. And that's the end of this video. See you later, Savers.